Okay, so in this video we're going to go over the test practice questions for a stoichiometry test, and I've given you just 4 examples. Some of them are pretty involved, so it's still a fair amount of work. I do want to make sure that you have tried the problems before you watch this video and do the Edpuzzle. It's for your benefit to prepare you for the test. And when I say try, I mean put everything away except for your periodic table and your calculator and see how much you can do. All 4 of these problems require you to come up with a balanced equation. You won't have to do that on all of the problems on the test. I've just given you maybe some slightly more difficult examples just to make the test hopefully a little bit easier for you. And even if you do struggle to come up with a balanced equation, again, before you complete the rest of this Edpuzzle, the rest of this video, I want you to do the stoichiometry even if you think you have the wrong balanced equation, just to practice setting up the problems and doing the conversions. Very important that you do that. It's also very important that you do that on the test as well. Even if you think you have the wrong formula, wrong balanced equation, do the stoichiometry. As far as this review goes, you can always go back and fix it very easily with just a little bit of erasing and replacing stuff. So it is worth your time and effort to do that. Okay, so let's get into the first problem. So how many milliliters of 1.55 molar copper 1 sulfate are needed to react with 17 grams of aluminum? Now, before we even worry about planning the problem, we should come up with a balanced equation, right? So this is a single replacement reaction because we've got copper 2 sulfate, which would be Cu2SO4 because sulfate is -2, reacting with aluminum, and so that's going to give us aluminum sulfate. And again, we have to balance charges, and it's going to give us copper. Similar to the lab that we did, but it was copper 2 sulfate. This is copper 1 sulfate. In terms of balancing, it looks like I need 3 sulfates on the left because I have 3 on the right. So I put a 3 there, and then that means I have 6 coppers, and I need to have 2 aluminums, and we should be all balanced. So then in terms of planning the problem, we're going to start with our 17 grams of aluminum. And actually, I don't even need to write 17 grams. I can just say grams AL. And then what would the sequence be to take me to what I'm being asked for, which is milliliters of Cu2SO4. Okay, so hopefully you said that to get milliliters we would need liters, and to get liters we would need moles of Cu2SO4, and to get moles of that we would need moles of Al. Okay, so setting up the problem then, doing the stoichiometry, I'm going to start with 17 grams of aluminum, and then grams of Al would be taken to moles of Al. Always make sure that you're complete in labeling your units. Don't just put grams and moles. Label what they are grams and moles of, in this case aluminum. And I'm going to go through and just fill in all my units first, and then I'm going to worry about numbers. So moles of Al has to cancel, and if I follow my sequence here, I'm going to go to moles of Cu2SO4, and then from moles of Cu2SO4, I'm going to go to liters. And then finally from liters to milliliters. And so then I'm going to go ahead and put my numbers in. Probably start with the easiest one first. There's 1,000 milliliters in a liter, right? This molarity is 1.55, so that means I have 1.55 moles per 1 liter. The mole-to-mole ratio, Cu2SO4, is 3, Al is 2. and then the mole to gram ratio comes from from the periodic table. And if I look at the periodic table, the mass of aluminum is 26.98 grams. Go ahead and cancel everything that cancels, which should be everything right up to milliliters of Cu2SO4. So you should have already calculated if you didn't get this far when you did it on your own. Go ahead and calculate it now and see what you get. Okay, there you go. So I got 609.7 milliliters, and that rounds to 610. Okay, so let's move on to the next one. For this one, let's see if you can come up with a balanced equation. How many grams of NH3 would you expect to produce from 22.5 grams of nitrogen and 5.5 grams of hydrogen? Okay, there you go. So you should have come up with that. It's a synthesis reaction. NH3 is being produced, and then we have to balance with the 3 and 2. Okay, so the next question is, what kind of problem is this? If I say how many grams of NH3 would you expect to produce, what's another name for that? Okay, so hopefully you said that we're trying to find theoretical yield because NH3 is being produced, and it's saying how much would you expect to produce. So we're looking for the theoretical yield in this problem. We're not given an actual yield, we're not being asked for a percent yield, but we are being asked for a theoretical yield. Okay, so the next question is, or the next thing we have to look at is, if I'm given 22.5 grams of nitrogen, so I'm just going to label that 22.5 grams, and 5.5 grams of hydrogen, what's going to be my first step in finding the theoretical yield? Okay, so you should have said that before we can find the theoretical yield, we have to figure out which one is the limiting reactant so we can calculate theoretical yield from that. So the way that we would do that is go from grams of one reactant, and again I usually just pick the first one, 22.5 grams of nitrogen, to grams of hydrogen. So go ahead and give that a shot. Okay, so I got 4.87 grams of hydrogen. And what does that mean? What's the significance of the 4.87 grams of hydrogen? Okay, so hopefully you said that the 4.87 grams of hydrogen is how much I need, and therefore since I have 5.5 grams of hydrogen, that means that hydrogen is my excess reactant and nitrogen is my limiting reactant. So what would be the next step in this problem? So the next thing we're going to do in this problem is use the 22.5 grams of nitrogen, just like we started with here, only this time we're going to go to grams of NH3, which is what the problem is asking us to find. In other words, we're going to use our limiting reactant, 22 grams of N2, to determine our theoretical yield, grams of NH3. So go ahead and do that. Okay, and so I got 27.4 grams of NH3, just a gram to gram conversion. And by the way, if you have any questions about any of the steps that I've taken that I'm not explaining, just make a note of it right there on your sheet and bring it into lab or bring it in after school to ask questions. But this is just a gram to gram conversion, and we get 27.4 grams of NH3. So once again, that would serve as the theoretical yield of NH3. And if we were given an actual and asked for a percent yield, then that would be our theoretical that we would divide the actual by. So, but in this case, the problem is done. Okay, problem 3. If 33.5 grams of magnesium reacts with 45.45 grams of aluminum oxide to produce 21.2 grams of aluminum, what's the percent yield? Okay, so see if we can come up with a balanced equation. Okay, so there's our balanced equation. What I want you to do now is take a look at what you're given. 33.50 grams of magnesium, 45.35 grams of aluminum oxide, and 21.2 grams of aluminum. And I just want you to think about what the steps will be in solving this problem. It's asking us for the percent yield. So what order do we go in solving this problem? Okay, so you should have said that the first step, since we're given grams of both reactants, the first step is going to be to find the limiting reactant. The second step is going to be to use the limiting reactant to find the theoretical yield, because the 21.2 grams is the actual yield. So then the third step, the easiest step really, would be to divide the 21.2 grams, which is our actual, by the theoretical. So go ahead and do that first step. See if you can come up with the limiting reactant. Determine which one is limiting. Okay, so I just calculated that I needed 46.8 grams of aluminum oxide to react with 33.5 grams of magnesium. I have 45.35, so what does that mean? Alright, so it means that I need more than I have for the aluminum oxide, which makes the 45.35 grams of aluminum oxide my limiting reactant. So that's my LR for this problem. So then the next step is going to be to find the theoretical yield of aluminum. And so go ahead and see if you can do that. Okay, so I got 24 grams of aluminum. And so what's the significance of that number? So 24 grams of aluminum becomes my theoretical yield. And then so what would the percent yield be for this problem? Okay, so there you go, 88.3% yield. We just did actual, which was given to us in the problem, divided by the theoretical, which we just calculated. Okay, so let's move on to the last problem. 74 milliliters of 0.55 molar zinc bromide reacts with 78 milliliters of 1.15 molar silver iodide. How many grams of solid precipitate would you expect to produce? So go ahead and come up with a balanced equation. Okay, so here's your balanced equation. It was a double replacement reaction. Once again, don't freak out if you messed up a charge, messed up a formula, didn't balance the equation correctly, forgot the charge on silver, whatever. Okay, it's only 1 point for the balanced equation. You should still move on with the problem even if you know you have the wrong balanced equation. Okay. This problem is also a little bit tricky because it says how many grams of solid precipitate would you expect to produce. So that's where you have to think about your rules, your solubility rules, and actually use the back of the periodic table, and you would determine like which one would be a precipitate, which one would not be soluble. And if you do that, and you should have your green cardstock periodic table, or at least your solubility rules in some form handy, you should find that the silver bromide is actually going to be that solid that we're looking for. So essentially it's asking for grams of silver bromide. So anytime you're given amounts of both reactants, in this case it's in milliliters and it's also giving you molarity. In the previous problem it was given to you, both reactants were given to you in grams, but anytime you're given amounts of both reactants, the first step will always be to figure out the limiting reactant. So go ahead and see if you can do that now. Remember though, they're in milliliters, so you have a little bit different process than if they were in grams. Okay, so I got 52.5 milliliters of silver iodide needed, and I went to milliliters of silver iodide because I was given 78 milliliters of silver iodide in the problem. So if I had gone to grams of silver iodide, the number that I get here for my answer wouldn't be something that I could compare to the amount given to me in the problem. So I have to go to a similar unit, milliliters of silver iodide. So at any rate, I get 52.5 milliliters needed, but I have 78. So I need less than I have, or I have more than I need, so that's my excess. So therefore my limiting reactant would be the zinc bromide. Okay, so the next step then says how many grams of solid precipitate. We already established that that's the silver bromide. So see if you can calculate how many grams of silver bromide would be produced. Okay, so there you have it. My solid precipitate, silver bromide, I'm expecting to produce 15 grams of it, and I base that calculation off my limiting reactant that I determined in the previous problem, or in the previous step. 74 milliliters of zinc bromide was my limiting, should produce 15 grams of silver bromide.